All right, subprograms part 2. In the previous topic or previous lesson, we talked about the foundation that we needed, which was scope and parameters. We can't really get into anything here unless you've already covered that. So if you skip that video, go back and watch it. So let me draw a picture for you for a second. Imagine you're in grade 12. It's the end of the year. You're hopefully going to walk across that stage and collect your diploma from the principal. It's a very exciting time for everybody. You get home, you unroll the diploma, you look at it, and you're like, wow, I earned this. This is mine. And when you read it, it says that it's an OSSD, Ontario Secondary School Diploma, and at the bottom there's a signature or two. One of those signatures will be the principal's signature. Now, if you're watching this video in 2020, then that's Mr. Berzesi at Stephen Secondary School. Who knows what it is when you're watching this video later on that. Anyways, so why does this matter? Well, imagine for a second that Mr. Berzesi has to sign 400 of these. That's about how many students we see graduate every year. That's a fair number. Now, that means that Mr. Berzesi has to sit down at his desk and handwrite his signature 400 times. Now, you might think, well, that's not that bad. Well, first of all, it's not, you've probably written an essay or written an exam or something like that really fast where your hand starts to cramp up, it gets sore, it gets tedious, you get bored. All these things kind of factor in. And not only that, when you're handwriting an essay or something like that, your hand's actually moving in different directions and doing different things. But when you're just doing your signature 400 times in a row, your hand is doing the exact same motions. Your wrist is doing the exact same motions 400 times in a row. That's actually pretty bad for your joints. That's how carpal tunnel happens. Anyways, so this is brutal. Not only is it bad for Mr. Berzesi, but it takes a lot of time. It sure would be nice if there was another way. Well, there is. There's something out there called a notarized stamp. A notarized stamp is basically a legal, meaning approved by some legal body, maybe a lawyer, maybe a judge or whatever. It's been approved by some legal body. And what that basically means is this stamp, a rubberized stamp of the principal's signature, can be used in place of his real handwritten one. So that means anything that requires the principal's signature, he could just pull out a pad of ink, slam that stamp onto the ink, and then slam it onto the document, whatever the document is. Maybe it's a check, maybe it's a diploma, who knows? It doesn't really matter. It is completely legal. So why does this matter? Well, think about that for a second. Rather than handwrite, now imagine it takes, 4 seconds per student, okay? Now 4 seconds times 400 students, that's 1,600 seconds worth of time. That's a fair amount of time. Now imagine if he's just doing it using a stamp. Well, that 4 seconds turns into probably about a half a second of hitting the ink, putting it on the page, bam, boom, 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 super duper fast. And not only that, he doesn't even have to be the one to do it. He could take that stamp, take the pad of ink, take the diplomas, and hand them off to somebody else and say, you do this. I got other things to do. I'm the principal. I got to run the show here. Come on, help me out. So that is a huge benefit. He's basically automated his work. Now, of course, there was a little bit of effort to make that happen. The stamp doesn't just appear out of thin air. There's actually a lot of manufacturing and whatnot that goes into building that stamp. So with a little bit of effort up front, Mr. Berzesi has created a tool that he can reuse over and over and over again. The only thing he needs is ink. As long as he's got ink, he can use that stamp indefinitely, forever, as many times as he would like. So what is the process of him actually setting up and building this stamp? Well, it's pretty straightforward. He has to sign his name on a special piece of paper. That piece of paper is then sent off to a company, and it's measured micromillimeter by micromillimeter to get the measurements perfect, and then a laser is used to cut out the rubber and make that signature exactly the outline of his make that rubber the exact outline of his signature, so it'll work and be perfect every single time. The only difference every time he uses it is what color of ink he decides to use, and that could be anything he wants. So that little bit of work on his part at the very beginning then equates into a ton of time savings and a ton of body savings in terms of his wrists and whatnot. So why did I tell you this little story? Well, because that's what we want to do today. We want to build something to automate our work. We want to take that 4 seconds and turn it into a half a second. Or in terms that we understand, we want to take those 4 lines of code and turn it into 1 line of code. That's our goal. So how do we do that? We do that using something called subprograms. Now, subprograms is exactly what it sounds like. Sub meaning a part of, or a mini. It's a mini program within our program. Now, you've already been using these. You've been using these since the very first day I taught you how to program with system.out.println. Println is a subprogram. We've been calling them methods. And that's all they are. It's just another name for it. So the problem in the computer science industry is nobody likes to agree on things. So there's a lot of names that represent the same thing out there for a lot of different terms. So without further ado, let's get into this. I've done a lot of preamble. A lot of this is everything that I've already talked about, so I'm just going to skip this real quick. Pop, pop, pop. Now, here we go. A subprogram, sometimes referred to as a method in Java, is a program within a program that performs a single task and can be reused to perform that same single task as many times as desired. Well, isn't that just the stamp? The stamp is that exact thing. It performs a single task and it can be reused to perform that same single task as many times as we desire. That's what our goal is. So we want to create subprograms, also called methods. You're going to hear me normally use the term method. Subprogram is more of a general term that's used across multiple languages, but in the world of Java, method is the much more accepted term we use. So I'm going to try and stick to that, but know that they do mean the same thing in case I slip up, because I do teach multiple programming languages. So, all right. So up until now, we've called these things code blocks for the most part. I would say, like, in this code block, you can define a local variable. Well, what I'm really talking about is a method. All right, those squiggly brackets, anything inside of those squiggly brackets. So here's a few methods that you've already been using. Println, pow, next line. These are all examples of subprograms or methods that we've been using since day one. We've actually learned a lot more than this. We've learned all of our string manipulation subprograms. We've learned all those math operations. These are all things that somebody else already created for us. We didn't have to do that. Well, that's fantastic. That's great. Why did they do that? Well, just to make our life easier, because the amount of effort that actually goes in behind the scenes for some of these subprograms is actually quite significant. And sometimes they're actually getting right down into the nitty-gritty and talking to the hardware to make these things happen. So, anyways, so note that we use subprograms potentially many times in a single program. Well, this is obvious. Like, just think of any task for homework or anything like that. How many times do you use the println command in a single homework question? Quite a few. So there is no limit to how many times we actually are going to need these things. Next line. For every single piece of data we get from the user, we have to use that next line method. So we can. Our goal is to actually create our own methods. That's generally speaking what we want. Now, setup, this just goes into the same thing that I mentioned before. Much like the principal stamp, he had to perform a little bit of extra overhead at the beginning and get that stamp created in order to actually use that stamp. All right? So just like when we want to create a variable, we use a variable, we have to define it first. Once we've defined it, we then have access to use it because it's in the Java dictionary. Well, when we define a variable, what we're really defining is a bucket that holds a value. When we define a method, we're creating a bucket that holds logic, an ordered sequence of instructions. And every time we refer to it by name, it's going to grab those ordered sequence of instructions and execute them. Just like if we refer to a variable by name, it's going to grab the value and bring it back to the program. But when we refer to our subprogram by name, our method, it's going to execute every single line in there from top to bottom. Now, of course, the stamp had a few little hitches to it. You could only use that stamp if you had ink. Now think about that. If you didn't have ink, you'd just be slamming your stamp on that page and nothing would happen. It would just stay blank. So the ink is required to do the job. Isn't that something similar to something we just talked about last time? A parameter. A parameter is data that's required for that method to do its job. Well, in our subprograms, in our methods, we may potentially need to create parameters in order to satisfy the task. All right, so there's some tasks that simply need outside information. Things like calculating the area of a rectangle. We talked about that example in the past, where basically we need to supply it with a length and a width. It can't calculate that without that data. All right, so again, just like the ink, we sometimes need a little support as well. All right, so there are two kinds of methods. There's a procedure, which is this lesson, and then there's a function. And they're very, very similar to one another. They only differ in really one way. So the next lesson is actually going to be quite a bit quicker than this one. So a procedure, that's what our focus is right now. For each one of these two things, procedure and function, we're going to learn how to define them, where to define them, and how to actually call it within our subprograms, how to use them within our programs. Now you already know how to use them because you've been using methods all along. The only difference is you're just going to add more to your toolbox, but the ones you're adding are ones you built. It's like building custom-built tools for your toolbox. It's pretty awesome, actually. So let's take a look at a procedure first. Formal definition. A procedure is a mini program within a program that performs a single task. That's it. It's just a workhorse. It just does work. That's it. So how many lines of code can be in a procedure? As many as we would like. Also as few as we'd like. There might be 1, there might be 10, there might be 10,000. I don't recommend 10,000, by the way. So println is a perfect example of a procedure. It just does work. It just displays text on the screen. That's all it does. So how do we define a procedure? Well, let's take a look. So here's the general syntax. All the yellow you see are things that you can customize. All the white you see is stuff that basically has to be there. So we see this private static void. That needs to be there. Okay, we're going to come back to what all these little parts mean in a second. But what do we get to change? Well, we get to change the identifier, the name of our procedure. Now, how do we name these things? Well, we name them the same way we name variables. We have to name them according to their purpose. What is the purpose of this method? What is the purpose of this procedure? All right, if it's to display user data, then call it something similar to that. All right, don't call it user data because it's not the user data. It's not the user data. It's an action. It's doing something. So the name should be reflective of an action. Inside, you see all the yellow for parameters. So you'll notice that they're actually defining new variables. We have a type and we have an identifier. So there's actually brand new variable definitions, and that's what they are. They're temporary variables that are defined every time we execute the code. Now you could have 20 of these, 10 of these, 2 of these, 1 of these, or none of these. You do not have to have parameters. It depends on what you're building. So inside, so you notice that we have our squiggly brackets. There's no semicolon at the end because it's not a command. This line here is a very special line. It's called a signature line. And the reason why it's called a signature line is that it's unique, like a real signature. It's unique in 2 ways. Its name and its parameters. Okay? So its name needs to be unique. It can't be you can't have any other procedures. Well, later on when you get to the grade 12, I'm going to teach you a little otherwise, but you shouldn't have any other procedures with the exact same name. And the parameters should be unique as well in terms of the number of them and the types of them, things like that. So that's your signature line. So if I ever ask you, what's the signature line of your method, that's what I'm asking for. Okay, so below that, you see we have our opening and closing braces. What that means is anything in between those braces belongs to this method. So whenever the method is called, all the code inside of here is going to execute from top to bottom. So if it's 1 line, that's all it's going to do. If it's 10 lines, it's going to execute them in order from top to bottom. All right. Yes, you can still have if statements in here. You can even call other methods from in here. You can't define them in here. You can call them in here. So for example, you could call println. You could call input.nextLine inside of here. No problem. So basically speaking, this is code that is executed fully whenever the subprogram is called by name. So let's look at a little example. So here's a very simple one that does nothing more than output user info. Well, what info? A name and an age. So we see the private static void has not changed. I've given it a descriptive name. You'll notice that we use a different naming convention. Instead of our variables, which use camel case, which means a lowercase first word, then every other word starts with an uppercase, method names always use mixed case, which means every single word starts with an uppercase. And for obvious reasons, so we can tell the difference between it and our variables when we're looking at our code. Inside of here, I have two parameters. Again, parameters are just there to help do the task inside. What are the values of name and age? I don't know. I have no idea. It depends on what we put inside the brackets when we call output user info. We're going to show a demonstration of that in just a second. So inside the code, all it does is display name colon, and then the name, age colon, and then the age. That's it. So let's break this down a little bit so you understand. So there's a ton of little components here. First of all, we have to have that keyword static because we're defining our method outside of the main. You can't define methods inside the main. You can use them, but you cannot define them in there. So we need that keyword static so it actually is usable within the main. The next is that keyword void. This tells Java that you're building a procedure specifically, not a function. You're building a procedure. Void means nothing. It means less than nothing. It means emptiness. And we'll come back to why we need that keyword there in the next lesson. The next thing is, of course, the identifier. And as I mentioned, it's in mixed case. It needs to be descriptive of its purpose. And then we have our parameters on the outside. Again, you could have some, you could have none, you could have many. And then we have our code on the inside. And this is obviously the meat of everything. So everything in this code is just going to flow from top to bottom. Okay, so where do we actually define our methods? We define them inside of our class, just below the main. So if we have 5 of them, they're all going to be defined in the same line, indented with the same way that main is. Okay, so for example, I'm going to slap it in right there. Now this program doesn't actually use it. All we've done is define it. It's like defining a variable, but not storing any, not doing anything with it. Even if it has a value, if we don't do anything with it, it's useless. And that's why you get that warning sometimes when you run your program. It says, you've not used this variable. Great. So right now we've just created basically a shell. And that shell is a container holding logic, but we're not using that logic yet. So that's coming up. So we now know where to define our code. All right. So it's time to stamp. It's time to actually put it on the page and make it work. Now remember, we can reuse this as many times as we want. So now that it's defined, we can freely use it as much as we please. We use subprograms in the exact same way that we use a variable. We simply refer to it by its name. That's it. That's all we have to do is just refer to it by its name. Now the trick is, though, if it has parameters, like in this previous one, like a name and an age, I have to give it a name and an age. I have to give it a string. In this case, I'd have to give it a string and then an integer in that order. Okay? Now, whatever I give it is going to be copied into this name variable, and the age is going, and the number I put in is going to be copied into that age variable. Okay, great. So the term we use when we want to use a subprogram, we want to execute it, is the term call. So we say we call a subprogram, we call the method. I call the print line method. I call math.pow. Okay? It's just the terminology. So again, if the subprogram has parameters, we have to satisfy that contract and we have to supply it data. So the next 2 slides is going to show you 2 ways that we can do that. The first way is to supply it literal values, actual numbers and words. The second is we're actually going to get the data from the user and we're going to supply it using variables. And you're going to see the difference in how the memory management works and things. Okay, so 2 slides. Literal values and then user data. So let's take a look at this. So here we have the exact same program we just saw 2 seconds ago. And now if I want to use literal values, I am actually going to put words and numbers in there. So I've called output user info 2 times now. Now watch how this executes. The program comes in the main, as it always does, and from here it's going to try and execute output user info. So it jumps down from here down to the signature line of output user info. And the first thing it does is it defines two new variables, name and age. And then it's going to copy the value Bob into the name variable. It's going to copy the value 17 into the age variable. Not until that is done does the code inside get executed. So now when it gets to here, name and age actually have values. In this case, Bob and 17. So that's going to get displayed on the screen. It's going to get to this closing bracket, and this is when some magic happens. When this closing bracket occurs, all local created variables get deleted. In this case, the only locally created variables are the parameters, name and age. So when it's done doing that, it comes way back up to where it was called and says, I'm done with you now, and go to the next line. And the next line says, oh, do it again, but this time with Judy and 23. So when we do it again, it jumps down to the signature line, defines two new variables, name and age, because they're not in memory anymore. So it's got to recreate them. It defines them again, name and age, and it's going to copy Judy into name, and it's going to copy 23 into age. And then it's going to, now that those variables have their values, it's going to come in, it's going to display them on the screen, get to that closing bracket, and as soon as it does, pop, pop, name and age are deleted. Comes back up to the program, continues on, there's nothing else, gets to the end, and our program is done. Now, some students have asked me, why do we need parameters at all, Mr. Lane? Why don't we just create global variables for name and age, and then we can just use those variables inside of the method without actually requiring the parameters? We can just set the variables inside of main and then call the method. Well, we don't do that for a number of reasons. The number one reason is that, as we talked about before, our goal should always to use local variables in order to save that memory. And that's the big one, right? So we want to make sure that we're not wasting memory for any given reason. Convenience doesn't make a program better. An ease of writing doesn't make the program better. Efficiency makes the program better. And we measure efficiency in two ways: speed and time and space. Okay, the easier way to think of it: time and space. Time being how much CPU time we're chewing up of the computer, space being how much memory we're chewing up. All right, so we want to try and reduce both of those or find a balance the best we can. So you should not be creating global variables and then just using those global variables inside of your subprogram. You should be using parameters and passing data into those parameters. So this was pretty easy to do. The data was just literally copied into the variables, and then we displayed it on the screen. So this is literal values, actual values. So let's look at it when it's user data. So we're actually going to create variables this time. So I've done the same thing we always do to get data from the user. We have our scanner, we have our input, and our subprogram down here, output user info, has not changed. It's still exactly the same. So inside of here, I'm going to, first of all, just demonstrate just using variables. So I've created a string called username, and I've set it to Fred. I've created a variable called user age, an int, set it to 21. You'll notice this time when we call the subprogram, we're not using literal values anymore. We're actually using the variables. So what gets put into name? Well, how does this work? Well, let's go down to the flow of the program. It comes in here, creates a variable called username that gets put into our memory, and Fred gets stored in that variable. Same thing for user age and 21. But then it gets down to this third line, and just like before, it says, ooh, I gotta go do that code. So it jumps down here to the signature line, and it says, ooh, define two new variables, please. It defines name and it defines age. So now we currently have 4 variables in memory: username, user age, name and age. Username and user age have the values Fred and 21. So when we create these parameters, it wants to get values for them. So where does it get the values from? So we see this username. Username does not get copied into name. The value in username does. So it's going to jump over to memory and say, wait, what's currently in username? Fred. Great, can I have a copy of you? Sure, here you go. So now we have a copy of Fred, and that gets dumped into the name variable. The same thing happens for age. We get a copy of the 21, and it gets dumped into the age variable. There is absolutely zero connection between username and name. So if inside of this method I change the value of name, it's not ever going to affect username. It only affects the local variable, which is called name. And then it works exactly the same way as we saw before. It executes the code inside, deletes any local variables, and then comes back up to the program and continues on. And in this case, oh my goodness, I got a lot of things going on here. That's everything I just said, by the way. All right, in the next case, I'm doing the exact same thing, but this time, I'm just simply getting the data from the user. Instead of just forcing it, I'm just getting the data from the user. And again, look at this line of code. It's 100% identical to the previous one. The execution is just going to be different because the user is going to be typing in the name and age. And it still copies the values stored in those variables. So that's it. So why do we use subprograms? We use subprograms for two major reasons. The first one is the one that we've already talked about, reusability, because we can use it and use it and use it and use it. In the beginning example I gave you, I said the reason why the principal would want to use the rubber stamp is so they can take that 4 seconds and turn it into a half a second. That's an efficiency check. All right, so it's going to take them a total of 200 seconds versus 1600 seconds to actually do that work. That's a pretty good change. That's a huge amount of efficiency, right? Okay, that's fine. So that's the big one, is reusability. Now, beyond that, the second one is the same reason that we use constants. We use constants so we don't have these magic values floating around in our programs. These magic values are just random or arbitrary numbers and text that we don't know what they mean. So we replace them with actual named values which have meaning now. So when I see that word pi, I know that that 3.14 is pi. It's not just magically an accident that it is 3.14. All right? So we use it for readability. It cleans up our code. So we can do the same thing with subprograms. In subprograms, if we have a big chunk of complicated code that's doing something crazy. Maybe it's checking to see collision between all the objects in the game you're building. So we call that collision detection. So maybe it's doing all of that work, and that's an intense amount of work. Now imagine for a second you took that, and maybe it's 500 lines of code. You take that 500 lines of code that's sitting in the middle of your main method, and you drop it into a subprogram, a method, and so it's all sitting there. But in your main method, in that place of 500 lines of code, you put one line of code that says collision detection. Man, with that simple name, you know exactly what's going on. It's doing the collision detection. You don't know how it's doing it, but if you're curious, you can always go down into the method and go look. But if you're just trying to read the main method and understand what's going on, that cleans it up an intense amount. It makes your program infinitely more readable. So again, we have two reasons, reusability and then readability. So I think I went through all that. Yeah. So basically what you want to do is if you're ever doing something more than once, you want to create a subprogram so you can reuse it. So you're never doing something more than once, or at least the effort of it anyways. And if you have a complicated chunk of code that's related, and it's ugly to look at, and it's hard to follow, pull it out, put it in a subprogram, and replace that ugly chunk of code in the main code with a simple, direct, descriptive method name to call that function, or call that procedure, I should say, sorry. Okay, so that is our introduction to procedures. Next time we're going to look into that next type of subprogram, which is called functions.